Hi, I'm Sophie, and I'm going to be your tour guide today as we head beneath Busselton Jetty to explore our wonderful marine life. We're currently standing at the end of Busselton Jetty, which was originally built in 1865, and it started out at just 100 metres long, and during its lifetime as a commercial port, it was extended 9 times. The most recent extension was in 1960, and that brought Busselton Jetty out to the length it is today, which is 1.84 kilometres. So although we're nearly 2 kilometres out into the sea, the water here is just 8 metres deep. In fact, Geograph Bay is a very shallow, sandy bay, and predominantly on the seabed are seagrass meadows. Geograph Bay has an average depth of only 9.5 metres. The seagrass meadows within Geograph Bay are very extensive and also healthy. Geograph Bay is the second largest seagrass meadow in Western Australia, second to Shark Bay in the midwest of WA. The seagrass meadows are a really important habitat and act as nurseries for a lot of species who will spawn and hatch their larvae here in the protection of the seagrass meadows before those species head off on annual migrations. And these nurseries are very important also for commercial species, things like herring, salmon, blue swimmer crabs, and of course the western rock lobster. Contrasting that wide expanse of sand and seagrass meadows is Busselton Jetty. All of the hard surfaces like the pylons going down into the sea provide an alternative habitat for things like corals and sponges to attach themselves on. And the shade provided by the decking above creates a habitat found in very few places within the nearby environment. Busselton Jetty is home to over 300 resident species and has become known as Australia's greatest artificial reef. So come on down with me as we explore the marine life and see what's out of our windows today. So the Underwater Observatory, where I am today, was actually opened in 2003. It's a giant cylinder building, 12 metres high and 9 metres wide, and there's 4 different viewing levels on our way down to the sea floor. There's 11 large viewing windows spaced throughout each of these levels, and each window provides a glimpse out into the different zones in the marine environment. So starting off here at the surface, it's the intertidal zone, and it's the area where the air meets the sea. It's a very harsh environment and constantly changing, with the wind and the waves providing a very dynamic environment. The tidal variation in Geograph Bay is really small. We have an average depth of just 1.2 metres. Most of the time, the average tidal variation is 30 to 40 centimetres. And I've even seen on the tidal predictions a 1 centimetre change between the high and the low tides. Because of the harsh environment here, the marine life needs to be well adapted to these harsh conditions. And they're mainly crustaceans and mollusks, things with a hard outer shell to protect the soft little organism living inside. Barnacles are one of the most well-known crustaceans that inhabit the intertidal zone, as are rock crabs such as the red bait crab. Here at Busselton Jetty, we have Australia's largest barnacle, the giant rock barnacle, which can grow out to about 10 centimetres in length, and they'll sit just at the lower tide level. The barnacles are aquatic animals, and they actually breathe their oxygen from the water using a gill. And so when the tide goes out, or they're exposed to the atmosphere by the low part of a wave, the barnacles will seal themselves off to the outside environment and trap just a few millilitres of water inside that circular opening, and that will provide their oxygen until the next lot of fresh water comes back to the animal. Barnacles are a bit upside down. Their heads are cemented onto the piles and their legs are poking out of the opening. They have a modified feeding leg called a cirri, and these cirri will be forced out of the opening of the barnacle to catch any food particles that may be floating by. Quite lucky for the barnacle because it means every one of their meals for their entire lives is takeaway and home delivered. Mollusks such as mussels and oysters also thrive in this rough environment because it means the changing water movement provides a lot of food and nutrient flowing past. There's also some carnivorous animals that will feed upon the mollusks and barnacles, and the most prominent one here is called a droop snail. Now, there's not one easily in front of the window at the moment, but these carnivorous snails actually have super acidic stomach acid, and they'll crawl over the top of a barnacle opening and inject that stomach acid into the little opening, and it will dissolve the barnacle in just a matter of days. The snail's mouth is shaped like a straw, and they're able to suck out the dissolved barnacle as their food. It creates a lot of empty shells, empty barnacle shells on the piles, and these empty shells become habitat for a small fish called a blenny. The little blenny, you can see them darting around the rocky habitat on the piles, and they'll actually live inside that empty shell with just their small face. If we look just around the corner of our window, we should be able to see a school of fish. Negative, they've swum away. Let's go down a little bit deeper to see if we can find some schooling fish. Schooling fish are often found just beneath the surface, and at this time of year, the end of March and April, the migratory species that have spent the summer in Geograph Bay are fattening themselves up to begin their migration. So many of the species that we see in Geograph Bay utilise the Lewin Current either to transport their larvae southwards and also for themselves to aid them on their migration. The Lewin Current is the biggest ocean current that influences our marine life here in the southwest. And the Lewin Current is really unique in its own right. The Lewin Current is a southerly flow of tropical warm water that has its origins in the northern parts of Australia. It flows in a southerly direction down the west coast of WA. This is unusual because all of the other continents in the southern hemisphere have freezing cold water from the poles rushing up their western coasts. So the Lewin Current provides a really moderating influence, not only in the ocean, but also on our climate. This warm water begins to flow in March and April, which means our coldest months of the year, June, July and August, have a warming influence out in the ocean, and this gives us a relatively mild winter period. During the summer months, the cooler Kate's Current flows past Cape Lewin towards Cape Naturalist in a northerly direction. And this cold water from the Kate's Current provides a rush of meeting the nutrient poor environment by the Lewin Current. That's housed here during the summertime, using the bay as a nursery area for spawning and breeding purposes. Schooling fish at the surface, things like Australian herring, tailor, salmon, all really streamlined and muscular. These are your typical fish-shaped fish with a real torpedo-like body and a small triangular tail. They're often silver in colour, and the silver colour provides them camouflage. As you can see, the sunlight streaming through the surface of the water. It makes them look silvery and blend in from above, but also from beneath, they'll get that reflective property against the surface of the water. You can also see a few little bubbles that are getting mixed in just by the general movement of the water. And this is called atmospheric mixing. And it literally is the air above being pumped down into the sea. This process is really important for overall ocean processes. Not only does it provide oxygen to surface dwelling marine life, but it also acts as a transfer of heat because simply whatever is in the atmosphere is mixed down here into the ocean. The mixing of the warmer water coming in is what drives our ocean currents in conjunction with the wind. And here comes that beautiful school of Australian herring. Australian herring are a small pelagic fish. They can live up to 13 to 14 years. And during that long lifespan, they'll travel here from Geograph Bay and a little bit north towards the Perth metropolitan region. This southwestern corner, they'll travel right around, sometimes as far as Victoria, depending upon the year. And back again, as I say, every single year for their long lives. Australian herring are easily identified by a bright yellow eye and two black dots at the tip of their caudal fin, which is their tail. There's thousands of herring in this school, and pleased to say they're looking pretty healthy and getting a little bit rounded as they feed up before heading off on their long journey home. The herring will be replaced by the annual run of Australian salmon, so hopefully we'll get to see a salmon out of the windows today. On the jetty pylons themselves, you can probably already see how bright and colourful the invertebrate life is that's living on the piles is. Now, they do look a bit like plants, flowering plants even, but it's these unusual shapes and growths are able to survive on the piles because these animals don't have a backbone. These spineless creatures can grow into weird and wonderful forms because there's no spine that keeps them upright. It's a really interesting mix. There's over 150 different species of sponges and corals that live on our jetty piles. The corals are the orange fingers that you can see poking out from each of the structures. And all of the lumpy, colourful things are types of sea sponges. And together they provide a very complex source of habitat for these marine life living both on the piles and in the surrounding waters. We do see one of those droop snails on the pile here in front of the window. So as just before, these are the carnivorous snails which feed upon the barnacles. So he's obviously had a bit of a feed up at the intertidal zone and coming down here to digest its food for the next couple of days before he'll head back up again. So at the surface, the sea sponges and corals are quite short and often grow flat against the jetty piles. However, as we go deeper down into the ocean, at depths of between 4 to 6 metres, the invertebrates on the jetty piles can grow out into what would be more known as their true forms, without the impact of the wind and the waves constantly pounding against these spineless creatures. The growth forms can often be quite bulbous for the sea sponges, and the coral fingers are enabled to grow out into quite long structures, 30 to 40 centimetres lengths. And it's down here that we do start to see some of the greatest diversity in our marine life. So through the next window, what we can see is one of our oldest jetty piles. This jetty pile is about 70 years old and represents in what would be seen as a complex and mature community of invertebrates that are settled beneath Busselton Jetty. So you can see that the corals are this orange colour, and just towards the top of the window, the little white polyps are being exposed. So these corals are soft corals. Unlike the hard corals that you'll find on the Great Barrier Reef that will grow and form a reef community together, these corals can survive in darkness essentially. They don't photosynthesize and are entirely carnivorous. They'll use those white little polyps to catch any plankton that's floating past in the water column. The sea sponges are simply all of those lumpy and colourful things. The chunks of blue and yellow, there's even pink and purple and green sea sponges. And a lot of people are really surprised by the vibrancy of the colour that the sea sponges represent. And you've probably all seen a sea sponge washed up on the beach. And by then it's a brown and very stinky ball. When a sponge is alive, that living sponge and tissue um, is what is filtering the seawater. So a sponge as big as your fist, and you can pick one out that you can see on the piles. A sponge that size will filter about 9.5 litres every hour. And that for you is just a regular bucket that you've got at home. The fish that swam by just then, the browny black fish, lives around this pile, and I'm sure that it'll be back again. It's called a scaly fin. Quite a territorial and aggressive little fish, not even scared of scuba divers. All of this growth on the piles, and there's a lot of jetty piles beneath Busselton Jetty, almost 700 of them, and many of them are colonised much in this, to this same level here. All of this complexity of growth on the submerged structure provides a lot of habitat for small fishes living amongst there. There's worms, small clams, little crustaceans, and those smaller creatures are literally fast food and easy pickings for a whole array of reef fishes. And it's the reef fishes which are residential that we begin to see as we get closer down to the seafloor habitat. Little things like the wrasse. I think we can just see a wrasse, a little black spotted wrasse, looking around for some worms in here. The female black spotted wrasse loves to eat little worms called polychaetes, which are often found on the outside of sea sponges. And the reef fishes exhibit quite a variation. Oh, here's our scaly fin looking in. Are you going to get him? Oh, there's his tail. Not so shy. The reef fishes exhibit quite a difference in their coloration and also in the shape of their body shape and the structure of their fins. There's no need to swim quickly away from anywhere or for long distances because all of their needs can be serviced within this short community. So many of the jetty reef fishes are found here. They'll be born here. They might not swim more than a few hundred metres from the little rock where they were hatched as a larvae. So down on the sea floor, the water depth is about 8 metres, and this is 24 feet in the old measures. The seafloor habitat is very different to what is found either side of the jetty in Geograph Bay, where the main habitat structure are seagrass meadows. The seabed around Busselton Jetty is littered with old debris and fallen pylons from years of jetty construction and also from devastating things such as the 1999 fire here at the end of Busselton Jetty. Whilst those things have been devastating and there's been a lot of construction through the jetty's life, all of the remnants and history related to those events on the seafloor creates lots of interesting nooks and crannies across the seabed, and these provide great habitat for things like octopus and cuttlefish. Now, both of these cephalopods are very hard to spot because they're masters of disguise and can change their skin colour and the texture of their skin through specialised cells called chromatophores and leucophores. The change in these, the appearance of these animals can be almost instant. So we're usually looking out for a rock walking across the bottom, or perhaps a tentacle poking out of the rock surrounding the base of the observatory. Sometimes we've seen an octopus waiting in stealth with just one tentacle raised in the sea, in the rocks around the base of the observatory, trying to catch a little fish called a black-headed puller. And these are small damselfish with a black face and a yellow stripe down the back of their body. These are related to other damselfish, a very famous one, which is a clownfish called Nemo. There's a little scaly fin. And the damselfish are highly residential. There's lots of families of black-headed pullers around. They lay their eggs in the rocks around the observatory, so you'll always be able to see some of those here. There's over 100 different types of reef fishes which we see regularly through the observatory windows, and our marine life has been monitored twice daily since about 2011, where we're identifying all of the species we can see but also counting them. And it's these measures of identification and abundance of animals which is showing us that by having a marine protected area here at the end of the jetty, we're able to increase the diversity and the abundance of these species by giving them a safe haven where there's limited man-made influences. This data set, in conjunction with our water temperature monitoring program, has also been able to track things like quite a devastating marine heat wave in the years of 2011 to 2013. And steadily, we're also tracking impacts of climate change locally when the oceans are warming, and they are here off the West Australian coast. We're able to identify any vagrant species that move down from the tropics and take hold in our local habitat. So that is bringing us now to the conclusion of our tour. There's a lot to see through the Underwater Observatory. It's one of 6 only natural aquariums in the entire world, and quite lucky to have one here, very accessible here in Western Australia. We don't feed the fish. There's no nets or cages that keep things close by. It's quite a surprise every day what you do get to see, and every tour can be remarkably different. Thanks a lot for joining me today on our underwater adventure. We'd love to see you here in person soon. Meanwhile, head through our website. We've got lots to learn about our marine life with our fish finder. You can read about our marine research on our researchers pages. And don't forget our gift shop. We've got educational things such as books and other things such as the Adopt a Marine Creature program, where you can donate to my work here conserving the marine life at Busselton Jetty. Thanks.